Hello, welcome back to the channel. In this video, I'm going to discuss Cambridge International AS Physics Paper 1, Multiple Choice, October-November 2024, Paper 1, Variant Number 1. Are you ready? Let's get started. Number 1, what are the SI-based units for the moment of a force? First thing you have to do is to recall the definition of moment. Moment is being defined as, this is a symbol of moment, and this symbol is called tau. Force multiplies by perpendicular distance. Now, second step, you have to look back at the question. The question wants the unit in the form of base units, in terms of base units. So that is why I try to simplify my equation. F, okay, what do you remember? F is equal to MA. Just write down whatever equation that you remember. Perpendicular distance is just distance. M is the mass. Mass, the standard international unit of mass is kilogram. Acceleration, the standard international unit of acceleration is meter per second square, and multiplies by perpendicular distance. Distance or perpendicular distance or parallel distance, they share the same unit, which is meter. Now, after that, all you can do is just multiplies all the units. So this is kilogram. Meter multiplies by meter, you get meter square. And second, -2. Therefore, the answer is D. Number 2, which statement about vector quantities is correct? First of all, recall. What is the definition of vector quantities? They are the quantities that have not only the magnitude, but also directions. Right, let us look at A. Acceleration of free fall is a vector quantity, which is true because it has a constant magnitude. That is not the statement about vector quantity, because acceleration of free fall, yes, it is a vector, but not because it has a constant magnitude, because it has a direction which is going downwards. Now, this explanation is wrong. B, temperature in degrees Celsius is a vector quantity because it can be positive or negative. Temperature, I want you to remember, temperature is one of the base quantity. All the base quantities are scalars. So temperature is a scalar quantity instead of vector. See, time is a vector quantity. Time has no direction. You cannot reverse back the time. So that is why time is a scalar quantity. Statement C is wrong. D, weight is a vector quantity because it has direction, which is true. The definition of weight is the gravitational force acting on a body, directing downwards towards the center of the earth. D is the answer. Number 3, this is a repeated past year question. The density of the material of a rectangular block is determined by measuring the mass and linear dimensions of the block. The list shows the results obtained together with their uncertainties. Density is calculated to be 2.5 gram per cm cube. What is the uncertainty in this result? Now, when you see long statements, don't be terrified by it. You have to look for the keywords. You have to look for the hint in the question itself, right? The hint given here is the density. So do it one step at a time. What is the definition of density? Okay, I just write down. The definition of density is mass over volume. Second step, look for another hint here from the question itself. Another hint, they told you this is a rectangular block. So, okay, this is how the block looks like. The length, the width, as well as, okay, the width is here. The height is 1. Okay, I have to redraw. Okay, this is the length. Okay, length and the width as well as the height. The height is 1 cm, the width is 2 cm, and the length is 5. Okay, this is how it looks like. I'm not good in drawing, but I try my best to draw. Okay, this is the one. So this is the height, which is 1 cm. This is the width, which is 2 cm, and this is the length, which is 5 cm. So how do you find the volume of the rectangular block? You just multiply the length with the width and the height. As simple as that, right? I'm not going to change the cm, the unit cm to meter because all my units are in gram, right? Or and cm cube. So I'm going to remain the units given here. Now, what is the uncertainty? Oh, the value of the density, right? It's already been given, so you do not have to calculate twice, right? So just look at this equation itself, right? This is the equation, the definition of density. It involves division. Do you still remember how do we find what is the rule when it involves division? The rule is when a division is involved, you add its fractional uncertainty. How to find the fractional uncertainty? Very simple. Just put the absolute uncertainty divided by the value of the density equals, just add out the fractional uncertainty. Delta M over M, this is a fractional uncertainty of mass, plus delta V over V, but I have to simplify that. Okay, I make sure that V is calculated by length multiplies by width multiplies by height. So I have to add delta length over length plus delta width over width plus delta height over height. Now I can do it to find the uncertainty, which means the absolute uncertainty. Absolute uncertainty is delta rho divided by the value of density itself, which is 2.5. Mass is 0.1. Absolute uncertainty is 0.1. The value of mass is 25 gram. Plus length, the absolute uncertainty is 0.01. And the value of length is 5. Plus width, the absolute uncertainty is 0.01. The value of width is 2. And the height, absolute uncertainty of height is 0.01. And the value of height is 1. So what you do next is that you just add it out, everything together, and then multiplies by 2.5 and round it off to one significant figure. Another rule for absolute uncertainty is that the final answer must be in terms of one significant figure, which is 0.05 gram per cm cube. So the answer is C. Now, number 4, what is a reasonable estimate of the volume of one page of this examination paper? Since you have the paper with you, right? Volume, do you still remember? Back to volume. Volume is length times width times the height or the thickness of the paper, right? So you can use your ruler. Right, you bring your ruler, maybe 15 cm, maybe 30 cm, right? I roughly estimate the length is about maybe 30 cm, but I'm going to change it to millimeter later. So I use my ruler to measure, which is about 30 cm. Let me erase this, the volume. This is 30 cm. The width of the paper, may be about 0.1 mm because it is quite thin. And the height of a paper, the width of the paper, sorry, the width of the paper, oh, one page of the examination paper, right? The width maybe about 20 cm. Okay, so since I put it in cm and mm, I have to synchronize the unit. I convert my cm to mm because all the answers, all the choices are in millimeter cube. So 30 cm is about 300 mm, multiplies by 0.1 mm, multiplies by 200 millimeter. And then, okay, this is 300 multiplies by 200 multiplies by 0.1. I get about 6,000, right? 6,000 millimeter cube. So the answer is C. Sometimes, even though the question asks you to do some reasonable estimation, you can do some calculation, rough calculation to get closer to the exact answer. Number 5, an object is projected from horizontal ground at a velocity of magnitude u and an angle theta to the horizontal, which is being shown here. It hits the ground at a time t after it is projected. Assume air resistance is negligible. Can you see this is a hint given to you? So you ignore air resistance. Which statement does not describe the motion of this object? So we have to look at the choices. You have to read out all the choices one by one. Right. A, the horizontal component of the object's velocity is constant and it has a value of u cos theta. So horizontal component, you resolve into horizontal. Horizontal. Let us see. This is the velocity projected theta to horizontal. So you want to find horizontal, which is ux right here. Okay, so I use adjacent. Cos theta is equal to ux over u. Ux, initial velocity in the horizontal direction, which is u cos theta. And the first statement is true because horizontal component of the object's velocity is always constant, same value, right? And it has the value of u cos theta. This is correct. So A cannot be the answer because we have to find the statement that does not describe the motion. Right? B, the horizontal distance traveled by the object is tu cos theta. If you want to find the distance, do you still recall? Distance, speed is equal to distance over time. So if you want to find the distance, because the speed is constant, you are allowed to use this equation. Distance in horizontal direction is vt, which is equal to u cos theta multiplied by t. The second statement is also correct. C, the time taken for the object to reach the maximum height is t over 2. So the time taken, because this is projectile motion and we ignore the air resistance, so the time taken to reach the maximum height, right, is equal to the time taken to reach from the maximum height to reach the ground, because this is a symmetrical path. So time taken to reach the ground is t. Time taken to reach the maximum height will be t over 2. This statement is definitely correct. I'm going to write it nicely right here. Okay, this statement is definitely correct. T over 2. D, the vertical component of object's velocity is constant and has the value of u sine theta. U sine theta is wrong. So D is the answer. Now, question number 6. A person traveling on a motorway has a total distance of 200 kilometers, travels the first 90 kilometers at an average speed of 80 kilometers per hour. Which average speed must be obtained for the rest of the journey if the person is to reach the destination in total time of 2 hours, 0 minutes? Now, first of all, before we start doing anything, check for the hint. The hint is about average speed. So we have to recall the equation or the formula of the average speed. Average speed is being defined as total distance over total time. So since this person is supposed to travel with a total distance of 200 kilometers, this person has already traveled the first 90 kilometer. So, okay, I have to look at the time, right? So I am going to do this. Speed is equal to distance over time. For the first 90 kilometer, the average speed is 80 kilometer per hour. I'm not going to convert to meter per second because all the choices are in kilometer per hour. Distance is 90 kilometer per time. So I have to find out what is the time taken to travel the 90 kilometer. So it is 90 divided by 80, and I got 1.125 seconds. This is the time taken to travel 90 kilometer with the average speed of 80 kilometer per hour. So the remaining distance that I have to use 200 kilometer multiply, oh, not second, I'm sorry, this is hour, 1.125 hour. minus 90 kilometer divided by 2 hours minus 1.125 hour. So, okay, get an answer. So the answer is 125.7 kilometer per hour. So I round it off to 126. D is the answer. Number 7, a car of mass 1,200 kilogram has momentum 18,000 kilogram meter per second. What is the kinetic energy of the car? Right, first of all, you have two hints here. One is they ask you about the kinetic energy of the car, so I have to write that down first, and then the momentum is given, right? Two hints here. So you have to relate these two. Now, I am going to find the kinetic energy. Ke is equal to half mv squared. I have the mass of the car, but I do not have the velocity of the car. From momentum, right, I can find my velocity. Momentum is equal to mass multiplied by velocity. 18,000 is equal to the mass of the car multiplied by the velocity of the mass of the car is given, which is 1,200. So you just sub it in. 1200 times V. Make V as the subject. Your V is 18,000 divided by 1,200. So the answer is 15 meter per second. Sub into the equation of the kinetic energy. 1200 times 15, you square it, and you should be able to get 135,000 joules or 135 kilojoules. Number 8, a ladder is positioned on icy, frictionless ground and is leaned against a rough wall. Rough wall, remember, when the question mentioned rough, it means that there's a lot of friction. At the instant of release, it begins to slide down. Which diagram shows the direction of forces P, W, and R acting on the ladder as it slides, right? So this is a repeated past year question as well. Now, I teach you the easiest way to do it. First of all, you look at the weight. Since this is a ladder and it is in inclined direction, right? It is positioned in an inclined way. So weight must act at the center of gravity. So weight acting downward. It seems like all the choices are acting downward. So weights are correct. Now the second thing you need to do, yeah, look at the ladder. So this is a ladder. What happened to the ground? The ground is frictionless. Frictionless meaning to say that there's no friction, right? So if there's no friction, the normal reaction force between the ladder and the ground must be 90 degrees. So I look at A. Okay, this is 90 degrees. Seems correct to me. B, this is 90 degrees. Seems correct to me. C, I'm so sorry, it's not 90. D, I'm so sorry, it's not 90 degrees as well. Okay, last part. We look at P, force P. Right, wall is a rough wall. Due to the friction that this end of the ladder must overcome, because there's another force, which is a frictional force, that is why the normal reaction force of P cannot act 90 degrees. So, okay, you look at A. A is 90 degrees. This is wrong because the wall is rough. If the wall is rough, there must be another force to encounter, right, the frictional force by the wall. So the answer, okay, B, yes, the answer is B. Now, question number 9. A toy parachute is dropped from a bridge and falls vertically through the air, right? Through the air. That means air resistance is not being ignored. The graph shows the distance traveled by the parachute against time. Which region of the graph shows when the parachute is at terminal velocity? Now, do you still recall what is terminal velocity? Let me define it. Terminal velocity means maximum velocity. Okay, maximum velocity reached by the toy parachute when air resistance balances the weight of the toy parachute. So no air resistance, no acceleration, no resultant force, constant velocity. Therefore, okay, this is a distance time graph. Remember, you cannot choose C or D, or you cannot choose D. Why? Because this is a distance time graph. How to find velocity from the distance time graph? Right. Distance time graph, velocity is equal to the gradient of the graph. So to get a constant gradient, the graph must be a straight line graph. Therefore, the answer is B. Now, question number 10, a lift or the elevator consists of a passenger car supported by a cable that runs over a light, frictionless pulley to a counterbalance. The counterbalance falls as the passenger car rises. Some masses are shown in the table. What is the magnitude of the acceleration of the car when carrying just one passenger and when the pulley is free to rotate? So look for the hint, like what I always say. First, where's the hint? Okay, counterbalance will fall when the passenger car rises. That means counterbalance falling, passenger car will rise up. Second step, identify all the forces that are acting on this system, right? Okay, when the counterbalance fall, that means this is the weight of the counterbalance. I put WC means the weight of the counterbalance. And could you see that the counterbalance is attached to a cable? Of course, there must be tension by the cable. And look at the other side. This is a passenger car. So the weight of the passenger car, this is a weight of the passenger car. WP, I put it as WP. And then tension, of course, tension will be pulling upwards. Right? Tension is the force that is opposing the direction of the pulling force. Right? Now, I will form equation, right? So I'll form an equation on the counterbalance side first. Remember, counterbalance falls. Counterbalance fall, that means that the weight of the counterbalance must be larger than the tension of the cable. So the weight of the counterbalance minus the tension of the cable is equal to MA. MA means resultant force. I find the resultant force on the counterbalance side. So the weight of the counterbalance, the mass of the counterbalance is given, which is 640. To find the weight, you just multiplies by 9.81 gravitational acceleration. Minus tension is equal to the mass of the counterbalance, because this is related to only counterbalance, 640 A. So simplify this. Okay, I get 6,272 minus tension is equal to 640A. Put this as equation 1. And on the other side, right, could you see that passenger car rises? That also means that the tension on the other side of the pulley is larger than the weight of the passenger car. So tension minus the weight of the passenger is equal to the resultant force, which is equal to MA. So T minus weight of the passenger car, 520. Let me see. Okay, plus the passenger. You have to plus the passenger, which is 80 kilogram multiplies by 9.81 is equal to 520 plus 80 times acceleration. So tension minus 5,880 is equal to 600A. This is the second equation. So once you get your two equation, this is like simultaneous equation, a little bit of math here. I want to find, look at the question. The question asks you to find the acceleration. So to find the acceleration, I need to get rid of my tension, right? So I put equation 1 plus equation 2. So when you add it up, you get 6272 plus negative 5880, you get 392. Tension, you just cancel because negative T plus T is equal to 0. 640A plus 600A, you get 1240A. Make A as a subject. A is equal to 392 divided by 1,240. You end up getting 0.316 meter per second square. The answer is B. Round it off to two significant figures. Now, question number 11, a stationary ball of mass m is hit by the bat. The ball leaves the bat with a velocity v. The bat is in contact with the ball for a short time, delta t. What is the average force of the bat on the ball? If you recall, this is related to Newton's second law. Newton's second law states that the resultant force is equal to the rate of change of momentum. Right, so the rate of change of momentum, this is mv because the ball is initially stationary, u is equal to 0. So mu, the whole thing here is equal to 0 divided by delta t. So you have mv divided by delta t, and the answer is B. Number 12, a disk of mass m is moving across a horizontal frictionless surface with a constant velocity u. It collides with a stationary disk of mass 4m. The diagram shows the view from above of the motion of the two disks before and after the collision. What is the initial velocity u of the disk of mass m? Now, I look at the U is acting in the horizontal direction because you could see that when an angle is involved, you have to resolve it into two perpendicular direction. In other words, you have to resolve it into horizontal and vertical direction. I am going to resolve it into horizontal direction first because U is acting in the horizontal direction. So I put here horizontal direction. Everything must be resolved into horizontal direction. Remember that. So use the principle of conservation of momentum. Total momentum before the collision must be equal to the total momentum after the collision. Total momentum before the collision, this is related to only m because 4m is not moving. So you put m times the initial velocity in horizontal direction, and after the collision, could you see that m? Okay, I do for m first. M is moving to the right, and for m is also moving to the right. But I want to resolve into horizontal component adjacent, right? Remember, horizontal component, this is cos theta. I better write it here. Okay, cos theta or cos 45. I resolve it here. Cos 45 is equal to, this is in x direction, right? V in x direction. Okay, so adjacent Vx over 4. So Vx is equal to 4 cos 45. So momentum, remember that is the mass. Mass multiplies by final velocity for cos 45. And one more thing you have to bear in mind, momentum is a vector quantity. So you have to consider one direction as positive direction and the other direction, the opposite direction as negative direction. And I put positive. Do you know why? Because the initial velocity of mass mass m is moving to the right. I considered right as positive direction. So that is why I put positive. And what about 4m? Okay, let us look at 4m. I put in blue color. This is 4m. V for 4m, yeah? So I put Vx as well, but for 4m, you could see that 4m is also being resolved. The velocity of 4m can also be resolved into right direction. So I put cos 45 is equal to, only look at velocity because mass is a scalar quantity that does not depend on direction. So that is Vx as well over for V. So Vx is equal to V cos 45. Now you just add up. Mass is 4m and big M, sorry, capital M. So I write it nicely. Plus 4m This is V cos 45 degrees. Okay, that is V cos 45. Now, I try to resolve it. I try to simplify it a bit. I cancel all the M. I have U is equal to 4 cos 45. That is 2.83 plus 4 times V cos 45. You have 2.83 V. Put this as equation 1. And after that, because I have two unknown and I'm supposed to find the value of U, so I am going to resolve into vertical direction. So vertical direction. Vertical direction, initial momentum has to be equal to 0 because U is acting in horizontal direction. And now for vertical direction, I want you to look carefully. Now, I use different color, maybe, okay, I'm going to use different color, maybe green to show you. Right, so now you look at M. M, I resolve into vertical, which is going upwards. So vertical, I put up as positive, down as negative. Remember, so this is opposite. So opposite has to be sine theta. Sine theta or sine 45. I put it straight away. Okay, I highlight the equation 1 first. And I put this one as sine 45 is equal to V vertical over 4. Now V vertical has to be 4 sine 45. Right? Upwards is positive, so I put 4m, mass times velocity. 4 sine 45 degrees. And then what about 4m? Look at 4m. I am going to use different color to do it. So 4m, I'm going to use orange color. You see 4m, when I resolve it, it is going downwards. Down is negative. Remember, down is negative. So still the same thing. Sine 45 is equal to V vertical over V. So V vertical is V sine 45. But I have to put negative to this one, right? So plus 4m, but this has to be negative V sine 45. You know why? Because the V, the final velocity in vertical direction for 4m is moving in downwards direction. And I consider downward as negative. Right, so I get m, okay, I shift the negative sign to the other side. So I have 4m sine 45 is equal to m for sine 45 degrees. Now what you need to do is just to cancel the m first. Solve it, simplify it. For sine 45, I have 2.83. Oh, this is v, I forgot about the v. V is here. Okay. Now, this is 4 sine 45V, 2.83 V. Now, V is equal to 1 meter per second. Since you get your V, sub into equation 1. Now, equation 1, can I further it down here? U is equal to 2.83 plus 2.83 V. V is 1. Therefore, your answer is 5.65 meter per second. Round it off to two significant figures, you get 5.7 meter per second. Now, number 13, an object is dropped from rest on the earth. So I put U equals to 0 first. From a height of 2 meters. The same object is dropped from rest on the moon from twice the height. The acceleration of free fall on the moon is approximately 60% of the value of the Earth. Assume that there are no resistive forces acting on the object. What is the ratio, the speed of the object just before hitting the surface of the Earth and to the speed of the object just before hitting the surface on the moon? Now I better resolve it for Earth first. Right. This object is being dropped. Okay, this is Earth. Height 2 meters. When I draw, I can see it clearer. right, from rest. And then they ask about the speed. When you see a height is being given, there's another hint here. Look for the hint, like what I say. When you see there's a height and they ask you for the speed, always use principle of conservation of energy. So the initial energy will be GPE converted to kinetic energy. I am definitely going to use that on Earth. Gravitational potential energy is mgh, kinetic energy is mv squared, half mv squared. Then, second step, cancel the m first. Could you see that the mass of the object is not important at all? G on the Earth is 9.81, height is 2 meter, and you can find the speed. Could you see that? Half, okay? Oh, I forgot about the half. Don't ever make this kind of careless mistake. Make v squared as the subject first and then times up. Okay, is equal to, okay, I do it step by step. So to find v is equal to 9.81 times 2 multiplies by 2 and you square it the whole thing. So v is equal to 6.26 meter per second. Done. And what about the moon? The same thing, right? This is moon. So moon, I'm going to use different color, maybe blue color. Still using the same concept, principle of conservation of energy. Initial energy is mgh, is being converted to kinetic energy. Cancel the m. Right, the gravitational acceleration on the moon is approximately 16%. So you write 16% divided by 100 times 9.81. And only you times the height is twice the height. Twice the height, initial height is 2 meter. Twice the height, you times 2, right? Which is equal to half v squared. Now, when you make V as the subject, V is equal to 16 times 9.81 times 2 times 2 and multiply, cross multiply the 2 to the other side over 100. And then when you square root it, you should get 3.54 meter per second. So when you want to find the ratio, you just sub in the values. So the ratio of the speed on Earth is 6.26 and the ratio of the speed of the object on the surface of the moon is 3.54. So the ratio is 1.77, or you round it off to 1.8. That's the answer. Number 14, the graph shows how velocity v varies with time t for a bungee jumper. At which point is the bungee jumper momentarily at rest, and at which point does she have zero acceleration? Jumper at rest, this is a speed time graph. That means the speed must be equal to 0, which is r, right? So you cancel a and b. This is between c and d. And this is a speed time graph. How do we find the acceleration? Acceleration is equal to the gradient of the graph. If you get zero gradient, that also means that the acceleration is equal to 0. So at Q, could you see that? Tangent that I drew is horizontal. Horizontal line will always give you 0 gradient. That is why Q, is the point where the jumper has 0 acceleration. Now, question number 15. A solid sphere, which is less dense than water, is held completely immersed in water a few meters below the surface. Density of the water is uniform, which is good news. That is another hint. Could you see that? The sphere released, and immediately after release, the sphere rises. Which row describes the changes in the magnitudes of the upthrust on the sphere and the resultant force on the sphere as it rises? Right. Now, check for the hint. What is the upthrust force? F is equal to rho Vg. Could you see that? Upthrust force is by the water. Since the question mentioned density of the water is uniform, this is uniform. And the volume, right? So the volume is also uniform. Nothing has changed. G is also constant. Nothing has changed. That is why your upthrust must be constant. What about the resultant force? Resultant force, right? Resultant force depends on the upthrust and on the weight. Since the force, since this is the sphere and the sphere is rising up, this is the upthrust force acting on the sphere. And then this is the weight of the sphere. right? Could you see that? When the sphere is rising up, keep on rising up, right? So what happens to the resultant force? The resultant force is equal to upthrust minus the weight. So since you minus something, the resultant force is actually decreasing. A is the answer. When you deduct something, don't you think you get lesser? That is what I meant by decreasing. Now, question number 16. A uniform bar of weight 200 Newton and a length of 4 meter is freely hinged on a wall at one end. The bar is horizontal and is held in equilibrium by a cable attached at a distance of 0.5 meter from the other end. The cable is at an angle of 35 degrees to the horizontal. What is the tension T in the cable? Look for the hint. The hint is that some of us, sometimes we don't know which equation to be used. When you see hinge, when you see pivot, when you see fulcrum, when you see axle, this is definitely the principle of moment. And another thing is that they told you this is a uniform bar. Uniform bar means the weight of the bar has to act at exactly the center of the bar, which is at 2 meters from both ends. So this is where the weight is acting, 200 Newton. So you write that down right away. Right. Okay, what is the tension? Okay, this is a tension and this is my pivot. Just use the principle of moment, anti-clockwise moment equals clockwise moment. So for anti-clockwise moment, you have to identify the forces first. Right, I look at all the distances that are measured in horizontal direction. Therefore, I would like to resolve my T, tension, in the vertical direction. Because I want to find moment, force and distance must be perpendicular to each other. So this is vertical direction. Right, for vertical direction, I am going to do it here. Could you see that? This is vertical direction, T, or I redraw here. This is the tension. And this is a horizontal direction, 35 degrees. I want to find vertical, T vertical. So I'm going to use sine 35 is equal to T vertical over T. T vertical would be T sine 35. Remember that. So this is T sine 35. Done. And then, since we have already identified all the forces, I am going to do here. So these two are the forces. Now this is a pivot. And the next step that you need to do is that, okay, you look at the forces one by one. So I'm going to look at T sine 35 degrees first. You see, T sine 35 degrees is acting upwards. While going up, it will seek for the pivot, which is a turning point. So where is the pivot? The pivot is on the right-hand side. So this T vertical will have to turn towards the pivot. When it turns in this direction, this is called clockwise direction. And what about the weight of the bar? So the weight of the bar is acting downwards. And where is the pivot? It is still on the right-hand side, right? So going down while seeking for the pivot. So it will turn towards the pivot. Turn towards the pivot. This is anti-clockwise direction. So once we have already determined our clockwise and anti-clockwise direction, all you need to do is sub into the equation of the principle of moment. Right, anti-clockwise. This is 200. Force multiplies by perpendicular distance. So the perpendicular distance must be 2 meters. Remember what I said just now? Because the bar is uniform, that is why the weight has to act at exactly the center of the bar, which is 2. And T sine 35. Where is the perpendicular distance? The perpendicular distance is not 4 because this is 0.5 meter. It adds here. And 4, you take 4 meter minus 0.5 meters. So the perpendicular distance is 3.5 meter. Don't make careless mistake, remember. Right, so the T that I got, T 200 times 2 divided by 3.5 sine 35, you should get 199 Newtons. So you round it off to 200 Newtons. C is the answer. Number 17. The diagrams all show a pair of equal forces acting on a meter rule. Which diagram shows the forces that provide the couple and zero resultant force, right? These what is couple? Zero resultant force, it means that the outward force is balanced by the downward force. So if you want easier, you do this resultant force first. A resultant force is not equal to zero because both forces are acting downwards. There are no upward force to balance the downward force. So A cannot be the answer. Eliminate the answer first. B outward force is these are all equal forces. So outward force is balanced by the downward force. So B could be the answer. C, outward force is balanced by the downward force. C could be the answer as well. D cannot be the answer because this is an angle right here. So you have to resolve in the horizontal component and the vertical component. So D will not give you zero resultant force. So it's either B or C. Now, couple. What is couple? Couple means two forces act first in opposite direction. Second, same magnitude. This is true, magnitude. Okay, and the third, separate by a distance. That means they cannot act on the same point. You look at C. C, two forces are acting on the same point, so it would not produce couple. Therefore, B is your answer. Number 18. A ball of mass m is thrown up to a height h in air. That means there's air resistance with an initial velocity v as shown. Air resistance is negligible. Okay, that is super duper good news here. That is why the path is symmetrical. The acceleration of the free fall is g. What is the total work done by the gravitational force on the ball during its flight from P to Q? So from P back to Q, P is on the ground, Q is also on the ground, right? So there is no work done by the gravitational force because P and Q are actually on the same point. Start at the same point, ends at the same point. So the gravitational potential energy is equal to zero. No work is done when you end at the same point. Right. Number 19, a spring of spring constant, 30 Newton per meter, is suspended vertically from its top. The spring obeys Hooke's law. Initially, the spring is not compressed and not stretched. A mass of 0.5 kilogram is attached to the bottom of the spring. Mass is released from rest and falls. Frictional effects are negligible. In the motion that follows, what is the maximum extension of the spring? Okay, so if you want to find the maximum extension of the spring, I am going to draw the spring first. This is a spring. And then spring constant, 30 Newton per meter. And then I attach a mass, which is 0.5 kilogram. And then release, so the mass will fall with the weight, right? Okay, understood. So in the motion that follows, what is the maximum extension of the spring? So when the mass is being hung on the spring, don't you think that the mass has a gravitational potential energy initially? Because the spring is suspended vertically, so there must be a certain height between the spring and the ground. So when the mass is being hung, the spring is being pulled down towards the ground, so which decreases its gravitational potential energy. So I'm going to use the principle of conservation of energy, which gravitational potential energy of the spring initially is converted to elastic potential energy of the spring. So gravitational potential energy is mgh. Elastic potential energy is half kx squared. H I am going to replace with extension of the spring, right? How close it is to the ground. So mgx is equal to half kx squared. What you need to do now, cancel this, and you make x as the subject. Now, X is equal to mg times 2 divided by K. M is the mass, 0.5. G is 9.81 times 2 divided by 30. So you get 0.327 meter, which is D. Number 20. A wire has original length L and cross-sectional area A. A tensile force F is applied to the wire, which causes it to have extension X. The wire obeys Hooke's law. What is an expression for the Young modulus of the material from which the wire is made? You should remember the equation of Young modulus: stress over strain. Stress over strain. Right. Now, stress is force over area, cross-sectional area, divided by strain, extension over original length. So Young modulus is FL over AX. Now F over A, L over X. So why not I do it this way? Okay, to match the answer to choices, F over A divided by strain. So the answer is B. 21, a wire is stretched by gradually increasing force. The force extension graph for the wire is shown. Which statement must be correct? Okay, let us look at the statement one by one. Now, point P is the elastic limit. Point P is the elastic limit. No, point Q is the elastic limit. Wow. Okay, it could be, but it could also be limit of proportionality. It depends on the material. Some of the material, the elastic limit coincides with the limit of proportionality, right? So statement A cannot be 100% sure. I cannot be 100% sure that it is correct. So right, it depends on the material. Now, B point R is the limit of proportionality. When you see a curve, it cannot be a limit of proportionality. That is definitely wrong. C, the area under the graph from P to S is the elastic potential energy stored by the wire. No, this is not the elastic potential energy stored by the wire. So elastic potential energy stored by the wire is when you release your force. You're not increasing your force. You have to, release your force, let the material go back to its initial dimension. That is called elastic potential energy stored inside the wire. D, the area under the graph from P to S is the work done in stretching the wire. That is true because this is the external work that you are doing. You are increasing the force on the wire. D is the answer. Must be correct. Number 22, a spring has an unstretched length of 0.3 meter and a spring constant 400 Newton per meter. An object is suspended from the spring and the spring is deformed within its limit of proportionality. The new length of the spring is 0.5 meter. What is the elastic potential energy stored inside the spring? So elastic potential energy, EPE, I am using half kx squared. So the spring constant is 400 and the extension, I have to take 0.5 minus 0.2. Final length minus original length, and I have to square it. Remember to square it. So you should get 8.0 joules. A is the answer. The next one. A wire consists of a 3-meter length of metal X joined to a 1-meter length of metal Y. The cross-sectional area of the wire is uniform. A load hung from the wire causes the metal X to extend by 1.5 millimeter and metal Y to extend by 1 millimeter. The same load is then hung from a second wire of the same cross-sectional area consisting of a 1-meter length of metal X and 3-meter length of metal Y. Both wires are extended within the limit of proportionality. What is the total extension of this second wire? So I have to do it one by one because, the hint first, right? Cross-sectional area. And then the length, And then, the extension, right? So when you see there's a cross-sectional area involved, length, extension involved, what you need to do is to find the modulus that is always Young modulus, stress over strain, FL over AX. Did you see that? Force and cross-sectional area are constants. See that? Now, because they didn't mention that these two wires are made of the same, these two metals, right? These two wires are made of the same material or same metal. So I cannot assume them to be the same. Therefore, the Young modulus of X is different from the Young modulus of Y. So I solve for X first. Young modulus of X is equal to force over A. The original length of X is 3 meter. The extension of X is 1.5 millimeter. Wow, okay, so 1.5. Okay, I just get the ratio. Is that okay? If you want me to convert to the standard unit, yes, not a problem. So I just convert to the standard unit, not a problem. This is 1.5 times 10 to the power of -3 meter. And then I get a value here. Young modulus of X would be 3 divided by 1.5 millimeter. I got 2,000. F over A is stress. So I just put stress multiplies by 2,000, right? Okay, this is Young modulus of X. Now, Young modulus of Y, F over A. Now, Y is 1, extension is 1 millimeter. So Young modulus of Y would be stress multiplies by 1,000. Now, after that, what happens is that they shorten the length of X and they prolong the length of Y. Now, still the same thing, Young modulus of X, stress multiplies by original length of X now is 1 meter. Extension of X, I don't know. And what about Y? Young modulus of Y, stress multiplies by the original length of Y has been changed to 3 meter. Extension of Y, I don't know. Now, okay, X and Y cannot be compared because they are made of different materials. I am going to compare X and X. Equation 1 is equal to equation 2. Now, stress multiplies by 1 over extension of X is equal to stress multiplies by 2,000. Stress and stress, cancel it off. Extension, okay, 1 over extension of X is equal to 2,000. So extension of X would be 1 over 2,000, which is 5 times 10 to the power of -4 meter. What about Y? Y, I do the same thing as well. Equation 1 is equal to equation 2. So stress times 3 over extension of Y is equal to stress multiplies by 1,000. Cancel the stress. And then 1,000 extension of Y is equal to 3. Extension of Y is equal to 3 divided by 1,000, which is equal to 0.003 meter. So total extension X total is equal to extension of Y plus extension of X. 0.003 plus 401, 2, 3, 4, 1, 2, 3, 4, 5, right? Meter, that gives you 0.0035 meter or 3.5 millimeter. B is the answer. See that? Now, question number 24. The graph shows the variation of the displacement with distance for a progressive wave at one instant in time. The period of the wave is 91 milliseconds. What can be determined about the wave? First, This is distance. From distance, we can determine the wavelength. Wavelength is here. Okay, wavelength lambda is equal to 4 cm. Period is given. From period, we can determine the frequency. Frequency is 1 over period. So frequency is 1 over 91 millisecond. 1 divided by 91 millisecond, which is equal to 11 hertz. So 11 hertz is correct. Wavelength, it is correct, right? B is wrong, right? And then let us determine the wave velocity. V equal to F lambda. 11 multiplies by 0.04. You have to change it to meter, right? Which gives you 0.44 meter per second. This is correct. A is actually correct. Now let us look at B is wrong. C, it is longitudinal wave. I cannot tell from the graph because both longitudinal and transverse waves can be represented by using a cos wave or the sine wave. The answer is A. Number 25, which group of electromagnetic waves is arranged in order from shortest wavelength to longest wavelength? So if you memorize this, I have already memorized. Start with the radio wave, microwave, infrared, visible light, UV, ultraviolet, X-rays, and gamma ray, right? So increasing frequency. So once they want the longest wavelength, shortest to longest wavelength, so I have to do it in the opposite manner. Radio wave has the longest wavelength. This is wrong. I want from the shortest to the longest. Visible light is here. Could you see that? For B, visible light is here, but the microwave is here. Microwave has a longer wavelength as compared to the visible light, but infrared has the shorter wavelength, so this is wrong. C, visible light, visible light has a longer wavelength as compared to ultraviolet. This is wrong. So D, X-ray, infrared, and microwave. D is the answer. Number 26, a wave has a frequency of 5 gigahertz. This is one of the prefixes. What is the period of the wave? Period is equal to 1 over frequency. 1 over 5 giga. Giga is 10 to the power of 9. You get 2 times 10 to the power of negative 10 second. Now we look at this one by one, right? 200 pico. Pico is 10 to the power of negative 12. So when you round it, okay, second, okay, put it 12, 11, 10. This is 2 times 10 to the power negative 10 second. A is the answer, but I will prove why B, C, and D are not the answer. B is 2 times 10 to the power negative 9 seconds, so definitely it's not the answer. C, 20 nanosecond, 20 times 10 to the power negative 9 seconds, so it is 2 times 10 to the power negative 8 seconds, definitely wrong. D, 20,000 micro. Micro is 10 to the power negative 6. 6, 5, 4, 3, 2. So it is 2 times 10 to the power of negative 2 seconds. This is also wrong. A is the answer. Number 27, 3 statements about 2 progressive waves are listed. Number 1, the waves have the same frequency. Number 2, the waves have the same amplitude. 3, the waves are emitted with a constant phase difference. Which statements must be correct for the 2 waves to be coherent? You should remember the definition of coherent. The waves must be constant phase different or zero phase different. Or they have to have the same period, same frequency. 1 and 3 are correct. Number 28, waves P and Q have the same amplitude. The waves meet in phase at point X and interfere to give a resultant wave with an intensity I. Amplitude of wave P is double. What is the new intensity of the resultant wave at X in terms of I? So I do P and I do Q. So for same amplitude, initially they are of the same amplitude, that's A. So resultant wave, okay, intensity is equal to constant times the resultant amplitude, A plus A, where you have to square it. I is equal to K, A plus A, 2A squared, you get 4A squared. First equation. Now, amplitude of P is being doubled, but the amplitude of Q remains the same. Intensity resultant is equal to K. Amplitude of A is 2A, but amplitude of Q is A. You square it. So if resultant intensity would be 3A, you square it, you get 9A squared. And you have to use the second equation divided by the first equation to get the intensity resultant intensity in terms of I. So IR divided by I is equal to K 9A squared over K 4A squared. Cancel whatever I can cancel. A squared, K and K. 9 over 4 I, which is equal to 2.3 I. The answer is C. Number 29, radio waves can be polarized, but sound waves cannot be polarized. Which statement gives the reason for this? A, radio waves are generally of a higher frequency than sound wave. That is not true. B, radio waves are transverse wave, but sound waves are longitudinal wave. Yes, polarization is a way to differentiate between transverse wave and longitudinal wave. Actually, the answer is B. Now, let us look at C. Radio waves can travel through vacuum, but sound waves cannot travel through vacuum. That is not the reason why the radio waves can be polarized. D, radio waves travel at much higher speed than sound wave. No, that is not the reason, right? So the answer is B. Now, number 30, light of wavelength lambda is incident normally on the diffraction grating with a total number of n lines in width W. A second order maximum is observed at an angle of diffraction theta. What is n? Now, when this is about diffraction grating, just write down the equation of a diffraction grating, which d psi theta, this is the second order, 2 is equal to 2 lambda. But the d, right? Grating spacing is not being given. Don't worry. Grating spacing is equal to 1 over n. N represents the number of lines per millimeter. So n, number of lines per, but the width is being given, so divided by width. See that? Now, okay, D can be replaced by W over N. So W over N sine theta 2 is equal to 2 lambda. And then across multiply W sine theta 2 is equal to 2 lambda N. Now make N as the subject. N is equal to W sine theta or theta 2 theta over 2 lambda. So the answer is C. Number 31, Kirchhoff's second law is a consequence of a basic principle. What is the principle? A, the charge flowing in an electric circuit is conserved. That is more in Kirchhoff's first law. B, the energy in an electrical circuit is conserved. That is what Kirchhoff's second law, right? Principle of conservation of energy. C, the sum of electric currents entering a point at an electric circuit is equal to the sum of electric currents leaving the point. This is Kirchhoff's first law. So this is first law. This is also first law. The sum of potential differences in an electrical circuit is equal to the sum of products of a current and the resistance. It is not potential differences, but it is more on EMF, right? That is why D is wrong. Now, number 32, the diagram shows a circuit with a light-dependent resistor, LDR. Ammeter reads zero current. That's a hint here. Ammeter reads zero current. It means that there's no current flows between these 2 points. When there's no current flow between these 2 points, VA is equal to VB. Potential difference at A is equal to the potential difference at point B. Right. When they ask about the resistance of the LDR, I will teach you the easier way to do it. First of all, Okay, you just consider this part of the circuit. I'm going to use this color. I'm going to use highlighter to show you. Just consider this part of the circuit first. Only this part. I'm going to use the potential divider concept. So potential divider concept, V output over V input is equal to R output over R input. V output is VA. I'm going to find VA. V input is 12, the total voltage. R output is the one that is connected between VA and 0 volt. Yeah, this is 30 over total. R input is the total resistance, 30 plus 10. So VA is equal to 30 times 12 divided by 40. Now get a value of your VA. VA is equal to 9 volt. I know this is 9 volt, right? So I know VB is also equal to 9 volt. VA is equal to VB. So VB is equal to 9 volt. Second step, because I'm supposed to find the resistance of the LDR, that is why I'm using this circuit. See carefully. I'm going to use this color, pink color, this circuit. Ignore the 30 kilo ohm and the 10 kilo ohm. So when I use this circuit, VB over the total input voltage, which is 12, is equal to the resistance of LDR over resistance of LDR plus 6. Now you get a value of VB, which is 9. 9 over 12 is equal to RLDR over RLDR plus 6. Cross multiply 9 RLDR plus 54, 12 RLDR. So move RLDR to the other side, you get 3 resistance of LDR is equal to 54. Resistance of LDR is equal to 54 divided by 3, so you get 18 kilo ohm. B is the answer. Number 33, a torch uses 3 lamps connected in parallel and powered by a cell of electromotive force. Okay, so I draw 3 lamps. Okay, I have to not be so biased. I draw same size. Okay, and then being powered by 3 volt. Right. Negligible internal resistance. Each lamp dissipates 0.6 watt of power. What is the current in the cell? So I find power of one lamp. One lamp power is equal to what is given? I use IV. Power 0.6. I need to find the current through one lamp first. Times 3. I is equal to 0.6 divided by 3, which is equal to 0.2 ampere for one lamp. Could you see that at this point, current will split? Right, so for 3 lamps, 0.2 times 3, which is equal to 0.6 ampere. C is the answer. Number 34. A cell with internal resistance is connected to a light-dependent resistor, LDR, a fixed resistor, and a voltmeter as shown. Voltmeter reading increases, okay? V increases. And which quantity decreases? Okay, I have to highlight this. Quantity decreases as a voltmeter reading increases. Now, the charge moving through the cell per unit time, the current. So the current is not decreasing. Current flowing through the cell is not decreasing, right? Because it is the potential difference that is across the voltmeter, which is being connected to the resistor, fixed resistor, is increasing. Now, let us look at B, the energy transfer to the fixed resistor per unit charge. It is not decreasing as well. That is the EMF, right? And C, the intensity of the light incident on the LDR. When the intensity for LDR, when the intensity increases, right? Which quantity decreases? So that also means that the intensity decreases. Intensity of the LDR decreases, the resistance of the LDR would increase. So intensity cannot decrease, because when the potential difference across the fixed resistor is increasing, then the potential difference across the LDR must be decreasing. So if the resistance of the LDR is increasing, right, because this is series circuit, V equals to IR, I is constant, V of the LDR is directly proportional of the resistance of the LDR. Now resistance increases, so the potential difference across the LDR must increase. So C cannot be the answer. Now, what about the terminal potential difference across the cell? This is decreasing. Do you know why? When the switch is being closed, some of the work must be done to overcome the internal resistance. So that is why it is decreasing. Number 35, the circuit shown contains a cell with negligible internal resistance. The energy transferred per unit charge in driving the charge through the complete circuit is E. Potential difference PD across X is V. I am going to write that down. The cell is then replaced with a different cell of the same electromotive force that has significant internal resistance. What is the effect on E and V of replacing the cell? Now, E is an EMF. So since the cell is being replaced with the same EMF, EMF would have to be constant. But the effect, which is the terminal potential difference, right? Due to the internal resistance, some of the energy must be used to overcome the internal resistance. That is why the V will have to decrease. Number 36. In the circuit shown, the batteries are identical and all have negligible internal resistance. All the resistors have the same resistance. The diodes have zero resistance when conducting and infinite resistance when not conducting. In which circuit is the current in the battery greatest? If you want the current to be greatest, the resistance must be the lowest. I look at A. Look at this. Both diodes are in forward bias. That means both diodes allow the current to flow. So the resistance here, if you put R and R, because these two resistors are being connected in parallel, right? So the total resistance would be half, right? How to get half? 1 over R total is equal to 1 over R plus 1 over R. So, okay, make R total as the subject. So since the resistance is half, the current will have to double, right? What about B? Okay, B, this is forward bias and this is also forward bias, R and R. So the total resistance will be 2R. What about C? C, this is reverse bias, no current flows through this. So the total resistance is just R. D, forward bias and reverse. So the total resistance is R. So you choose for the smallest resistance, R over 2, to get the greatest current. Because from the Ohm's law, since the potential difference across the battery is constant, I is inversely proportional to R because the V is constant. Now, question number 37. A potentiometer circuit is used to determine the EMF, electromotive force of a cell. The circuit includes the second cell of EMF 1.5 volt, an internal resistance of 0.5 ohm that is being connected to a uniform wire XY as shown. Resistance wire XY has a length of 0.96 meter and resistance of 0.5 ohm. The movable connection Z is moved along wire XY. Galvanometer reading is 0 when the length XZ is 0.64 meter. What is the value of the EMF E? If you recall, there's a relationship between resistance and other physical quantity. You know, resistance is directly proportional to length. That means longer the length, higher the resistance. And also resistance is directly proportional to the potential difference. So we can extend this, right, to say that using the potentiometer or potential divider concept, I am using this. V across XZ. Because V across XZ, you have to remember why the galvanometer reads 0? Because V across XZ is equal to E. Is that okay? Over the total V, which is 1.5, is equal to the resistance. I am going to find the resistance because resistance across XZ over R total. Where do I get my R total? These are all my R total. Now, it seems like I don't have resistance of X and Z, but I can use the length to find the resistance, right? So I know that the total length is 0.96 meter and the total resistance is 0.5 ohm. I only want to get 0.64 meter. What is the resistance? Do your cross multiplication. So the resistance of XZ is equal to 0.64 multiplied by 0.5 divided by 0.96. The answer is 0.33. Oh, so I just sub it in. Voltage XC or E, right, is equal 1.5 equal over 1.5. Resistance of XZ is 0.33 over the total resistance. You have to be extra careful. This is the total resistance of the wire, 0.96. Oh no, 0.5. You have to be careful. 0.5. Add with the internal resistance, 0.5. Right, now VXZ is 0.33 multiplied by 1.5 divided by 1. So you get 0. Let me see, 0.33 times 1.5. So you get 0.495 volt, sorry. So you get 0.495 volt. Right, still remember I told you that the E is equal to the potential difference across XZ. So 0.495, you round it off to 0.5. A is the answer. Number 38, the particle is, which particle is not fundamental particle? Right, a charm quark, yes, it is fundamental particle. Electron, yes, it is fundamental particle. Neutrino energy, yes, it is fundamental particle. Neutron is not, because neutron can be divided into quarks. 39, the isotope fluorine. 18, undergoes beta plus decay to form a stable isotope. How many neutrons are there in a nucleus of the stable isotope? So you have to form equation first. 18, 9, F, decay, 0, positive 1, beta decay to form 18, 9 minus plus 1, this is 8. Isotope, I just put X. Is that okay? So you want to find the number of neutron. Neutron, it is your nucleon number minus proton number. You get 10. So D is the answer. And the last question, which statement is correct? A baryon is a hadron that consists of 2 quarks. No, it consists of 3 quarks. So this is wrong. B, a meson is a hadron that consists of 3 quarks. No, meson consists of 2 quarks. C, electrons is a fundamental particle and it is a lepton, which is true. D, a neutrino is a fundamental particle and it is a hadron. Fundamental particle is called lepton, not hadron. Right? Lepton is the answer. So C is the answer. So that is all about our discussion, yeah, for 9702 October November 2024 paper 1-1. So if you need the PDF solution, all you need to do is look at the description I attach right in the description. So happy learning and thank you very much for watching. Right, I see you in my next video. Bye.